Hello friends, we'll be talking about probability in this session. So let's first talk about experimental probability. Now probability, as we know, is the chance of occurrence of a certain event. Now when we have the data of the total outcomes in an experiment and the number of times the required event occurred, then we calculate the probability, which is called experimental probability, because this probability that we get is based on the outcomes of the experiment that has been conducted. Now this is also called empirical probability, and this probability is given by the formula number of times the event occurred divided by the total number of trials. Now say for example we have team A and team B playing some match. So they may be playing some, say for example we take a cricket match. So these two teams have played, say for example, 10 matches together, and the event we define as the team A winning. So if we know that out of the 10 matches that they have played, team A has won 3 times. So that means that the number of times the event has occurred in this case, in this particular experiment, is 3, and the total number of times the two teams have played together is 10. So this becomes the empirical probability of team A winning the match when it's playing against team B. Now we can get this value of PE, which is the empirical probability, by repeating the same experiment 10 times, 20 times, 30 times, and so on. So for example, the example that we took, where two teams, team A and team B, have been playing against each other. Now if they play more matches, when they play 15 matches or 20 matches, the data may change. Now supposing they play 15 matches in all, and the remaining out of 10, team A had won only 3 matches. But say for example, if they won the remaining 5 matches that they played, so the total matches that team A won becomes 8 now. So the probability will become, the empirical probability of team A winning the match when it plays against team B becomes 8 by 15. Now this probability is purely based on the experiment, or purely based on the outcomes of the actual event happening. Now friends, let's talk about theoretical probability, and then we'll see how is it different from the empirical probability. Now theoretical probability is also given by the number of possible outcomes that make up an event divided by the total number of possible outcomes of the experiment. So by definition, probability is number of outcomes divided by the number of total outcomes. But the difference between the empirical probability and theoretical, if you see by definition, here this possible term comes. So it says theoretical probability is number of possible outcomes that make up an event divided by the total number of possible outcomes of an experiment. This is called theoretical or simple or classical probability. For example, if a fair coin is tossed, the probability of getting a head or a tail is the same, right? So why do we always say fair coin? Now supposing a coin is made in such a way that one of its surface is not plane. So it just, whenever you toss it, when it lands on the ground or on the hand, it rolls over because of the surface not being even. So that would not be a fair toss, fair coin. So we always talk about fair coin when we talk about theoretical probability, fair coin, fair dice, and so on. So we are saying if a fair coin is tossed, the probability of getting a head or the tail is same, because their total of two possible outcomes, which is either you may get a head or you get a tail. Now, the probability of getting a head is 1 by 2, which is total outcome 2. Similarly, for tail, the probability becomes 1 by 2. So we are saying the probability of getting a head or a tail is same, and this is the theoretical probability. So we put it in this formula. PE is equal to number of outcomes favorable to the event E, because the event E in this case we have defined, say for example, as getting a head. So we are saying number of outcomes favorable to that event will be 1. Number of all the possible outcomes of the experiment is 2. So the probability of getting a head becomes 1 by 2. Now let's understand a little bit more on theoretical probability. The theoretical probability PE will always lie between 0 and 1. Why? Because we are saying in an experiment, the total number of outcomes, whatever that number may be, will always be more than the number of outcomes which are favorable to the event that we're looking for. So the total number of events will always be at max equal or more than the number of the number of outcomes which make up the event. So numerator will always be less than or equal to the denominator. So, and it can obviously never be negative. It cannot be more than the denominator. So PE will always lie between 0 and 1. More importantly, we can also say that the numerator is basically always a subset of all the possible outcomes, which is the denominator. So numerator being a subset of the denominator will always have to be lesser than that. Now an event having one outcome of the experiment is called elementary event. For example, getting a 1, when you throw a dice, when you throw a fair dice which has 1, 2, 3, 4, 5, 6 written on it, getting a 1 has only one possible outcome, which is 1, and the total number of outcomes are 6. So now this event of getting a 1 is an elementary event because there is only one outcome possible. The sum of the probabilities of all the elementary events of an experiment is always 1. Now say for example we say that the probability of getting a 1 in the dice is 1 by 6. Again the probability of getting 2 is 1 by 6, and so on. The probability of getting 6 is also 1 by 6. So the probability of getting each of these numbers is 1 by 6, and if we add them, we get 1 by 6 plus 1 by 6 plus 1 by 6. 6 times we add that and we get the sum as 1. So the sum of probabilities of all events of getting 1 to 6 is 1. Now if we take up another event, like we say that an event is getting a number more than 3 when you throw the dice. Now the possible outcomes are getting a 4, getting a 5, getting a 6. Now I'm not saying greater than equal to, so I'm not going to take 3, I'm only going to take 4, 5 and 6, because the event that we've defined is getting a number greater than 3 when you throw a dice. So now there are 3 possible outcomes, and the total outcomes being 6, the probability of getting more than 3 is 3 by 6, which is half. Now this is first of all not an elementary event. So we can't include this in the sum of this, where we are saying sum of probabilities of all the elementary events of an experiment is always 1. Now if the probability of an event is 0, then it's called an impossible event. So if we are throwing a dice and we say, what is the probability of getting a 7? Now that is an impossible event because the dice itself does not have the number 7. So there is no possibility of getting it. So that probability will be 0 and it is called an impossible event. If the probability of an event is 1, that means it is a sure event. It's a certain event. It has to happen. Say for example, when we are throwing a dice and we say, what is the probability of getting a number between 1 and 6? Inclusive of 1 and 6. Now what is the probability? It definitely is 1. We will definitely get one of these numbers, and the event that we have defined is getting a number from 1 to 6 when you throw a dice. So now that is a sure event. That's a certain event. An event E bar, there's a bar over here, this represents that an event which does not have E, so it is not of E. It is also called complement of event E. Say for example, again we will continue to talk about dice so that we understand the different terms related to the probability using the same experiment that we're talking about. Now if we throw a dice and we define an event as 1, 2, getting a 1, 2 and 3. Now this is an event and its probability we know is 1 by 6. So the event which is complementary to this is getting a 4, 5 and 6. Getting anything other than 1, 2, 3. Now this is not of, now if this 1, 2, 3 is an event, this becomes E bar, which is complement of event E. Now another example we can take is, say for example, we are playing with cards. We have a pack of cards which has the standard 52 cards. Now the probability of getting a diamond card from a pack of cards and the probability of getting a spade, heart or a club card. Now these are complementary events because either you get a diamond card or you get something other than diamond card. Now if we are defining the event as getting a diamond card, so let's just make a symbol of this, getting a diamond card, then its complementary event E bar would be getting a card which is not diamond, which would mean that it is getting a spade, heart or a club card. So these two are complementary events. So E and E bar are called complementary events. Now if we toss 3 coins simultaneously and we have to find the probability of getting at least one head. So we are tossing 3 coins together and we are saying, let's see what is the probability of getting at least one head. So the options in this case would be, let's start with getting 3 heads. We'll have 2 heads and a tail, and the options could be HHT, HTH or THH. Now similarly, then we may have just one head and that would mean HTT. We may have THT and we may have TTH. And finally, when we have no head, so it will be all tails in this case. Now we are saying we have to find out the probability of getting at least one head. So now if we count these events, this has at least one head, this has, this has, this has, this has, this has, this also has, this does not have. So we can say out of a total events of 8, 7 are which make up the event. 7 outcomes are such that where we have at least one head. Now this is the probability of getting at least one head. This is one approach that we can take. Now the other approach that we can take is if we can find out the probability when there is no head, that is just one TTT, which is 1 by 8. And we know that the event that we're talking about where we have at least one head is complementary event of this where we don't have any head. So that would mean that we could simply subtract 1 by 8 from 1 and we get the required probability of getting at least one head. So this is where the concept of complementary events become very helpful. So rather than writing down all the events and counting, we could do other way around, which could be much easier in some cases. So that is where we have to identify whether we use complementary event concept or we directly count. Now these were just 8 of the outcomes which we could have written. But if in an experiment the possible outcomes are huge, then writing down all of them might not make sense, and that is when we might want to use the concept of complementary events. We first find out the complementary event, which is a much smaller one to figure out, and then we can get the probability of its complementary event. Because by using this formula where we say the probability of the complementary event is 1 minus the probability of the event. This is what we've done. 1 minus 1 by 8 gives us 7 by 8. Because if the two events are complementary, that would mean that their sum would be 1. Now friends, let's try to understand what is the difference between theoretical probability and experimental probability. First of all, theoretical probability is based on the assumption that the experiment is unbiased. So the first thing that we said is when we do the theoretical probability, we always say it's a fair coin, it's a fair dice, it's an unbiased dice and things like that. So the basic assumption is that the experiment is unbiased and the occurrence of every event is equally likely. So in case of a coin, it is equally likely to get a head or a tail. In case of a dice, it is equally likely to get a 1 or a 2 or a 3 or any number till 6. Whereas empirical probability is based on the actual experiments and their outcomes. So when we are saying, say for example, we say that find theoretical probability of getting a 1 when a dice is thrown. It is clearly 1 by 6 because the total possible outcomes are 6 and the probability of getting a 1 is, the outcome is just 1, so it becomes 1 by 6. But now when we were supposed to find the empirical probability, what do? We throw the dice, say 10 times. And out of that, we see how many times did we get 1. Say for example, we got 3 times we got 1. So we say 3 by 10 is the empirical probability of getting a 1 when a dice is thrown. And this is based on 10 observations that we made. And if we make 20 observations, that probability might change. Right? So now as we increase the number of times we perform this experiment, we'll keep getting closer to the theoretical probability. Now when we are throwing a dice, say for example 20 times, 30 times, 40 times and so on, then we'll keep getting the probability of getting 1 will keep getting closer to the theoretical probability. So as we said, we'll normally see that as we increase the number of times the experiment is repeated, the value of PE will keep getting closer to the theoretical probability, again in case of equally likely events. Now why do we say equally likely events? Supposing two teams are playing or two players are playing against each other. Now in that case, theoretically yes, both of them are equally likely to win. But if you see practically, what will matter is the match conditions, maybe the ground, maybe the weather conditions, maybe the health conditions of the player, maybe the fitness level, maybe the preparation level of the player and the skill of the player. So these are not equally likely events. So theoretically we can say if two teams are playing or two players are playing against each other, theoretically the probability of winning is 1 by 2 for both of them. But practically, which would mean the empirical probability that will come out may not be close, and it may not, even if we increase the number of times this experiment is repeated, we may not get anywhere closer to the theoretical probability. So now we toss the coin 10 times and note down the result, and we find out what is the probability for both head and tail events. So as we did in this case where we were rolling down a dice. So now if you keep increasing the number of times a coin is tossed, you will see that the result keeps coming closer to the theoretical probability. So we've already talked about when two teams are playing, will it come closer to the theoretical probability if they're playing more and more? Maybe not, because it depends upon other factors like skill, weather conditions, match conditions, ground, and so on. So friends, now that we've talked about theoretical probability and empirical probability, let's understand their difference from a use perspective. Where is which one used? So empirical probability is used in most statistical inference based procedures like exit polls, match predictions, etc. Now when we're talking about matches, we clearly know that the two teams that are playing against each other are not equally likely to win, because they're not at they may have their own strengths, each one of them may have their own strengths, and each one of them may have their own weaknesses, based on which there are a lot of conditions which will decide which team will win. And similar is the case with exit polls. So this is not based on we can't use theoretical probability that supposing there are 1,000 people who are going to vote. So the probability of candidate 1 winning versus candidate 2 winning, if we find out theoretically, it will come out to be the same. But exit polls are used to get the statistical inference, because these are not equally likely events. These are not equally likely things or unbiased things which happen. So there are changes, there are differences in how they will act. So that is where the empirical probability is used, and we never use theoretical probability. So in exit polls, in match predictions, etc., we always use empirical probability. Empirical probability can be used where either we have the past data of a similar event, or an experiment on a sample size can be conducted. So the two things that we talked about, exit poll, the past data will probably not help, because the the different parameters based on which the people are voting will change every time. In the previous election, it may be election, it may be any other thing which is happening. So I'm just taking an example of election. So in previous election, the preference of the people may be different, the candidates may have different characteristics, but this time they may have their own strengths, the mindset of the people might have changed, the requirement, the priorities of the people might have changed. So the past data, although it may be available that party A has always been winning, but this time you cannot base your predictions on the previous results. So although the past data is available, but that may not be helpful. A sample size experiment is what is used, and that is what gives, and that is what is extrapolated by using empirical probability to predict the results. Whereas in case of match predictions, we talk about the previous matches that those two players or those two teams have played against each other, in what kind of ground they have played, in which country or in which stadium they've played, in what weather conditions they've played, and other things are seen, and based on that past data, the probability is found, and that is what is the source for the match predictions. Theoretical probability is used where there is no data and experimentation is also not possible, or in some cases experimentation is not required, as the behavior follows the equally likely patterns. Now say for example, if you're tossing a coin or if you're throwing a dice, now there is no need to have any previous data. There is no need to have any experimentation done to find out about the probability, because they're all equally likely events. Even in the past, if something else has happened, this is simply based on the equally likely events and their theoretical probability. So we should use theoretical probability if we are gaming with dice. We should not be talking about empirical probability, that in the last 5 throws of a dice, since I've always gotten more than 4, I'll get more than 4 in the next time also. That is not how it's going to work, because these are equally likely patterns and they will work on the theoretical probability. Now, subjective probability involves human actions or behavior, and that is where we use experimental probability. So as we said, match prediction, that involves human actions, human behaviors, human skills, and that is where we use empirical probability. But we're talking about, if you're talking about cases where we have 5 bags, or we have 1 bag where different color balls or marbles are there, and we need to just we're blindfolded and we need to pick out a ball from that bag. Which color ball would it come? Now that is purely based on the theoretical probability. That does not need an experimentation, that does not need any kind of previous data to be available. So this is where the simple probability is used. Now if we take another example, say for example we're talking about games like deal no deal and other dice based games and all those, that is where we'll use theoretical probability, because again it simply is based on how it works, every event being like equally likely. But when we're talking about, say for example, insurance companies, they take some money from you and they give you insurance of a much bigger amount. Now that is based on empirical probability. They see that okay, if there are 100 people who are insured with us, out of those 100, how many have been claiming it in the past, and what is the amount that they've claimed, and that empirical probability is used to find out how much amount will they take from you for a particular amount of insurance, be it a vehicle insurance, be it a medical insurance, or any insurance for that matter. That has to be based on empirical probability, but because that is not an equally likely thing, that cannot be handled based on the theoretical probability. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.